This video covers some of the things that we can find using a velocity versus time graph. For the velocity versus time graph, the velocity is on the y-axis and the time is on the x-axis as shown. And the graph can look something like this. We can use this graph to find the velocity at any given time, or use the points on the graph to find the average acceleration or instantaneous acceleration, which we will talk about in another video. Let's do an example. We want to find the average acceleration from 2 to 7 seconds. Let's find the corresponding velocities at these times. So at the time 2 seconds, we see that the object has a velocity of 2 meters per second, and at the time 7 seconds, we see that the object has a velocity of 5 meters per second. Let's apply these values to our average acceleration equation, which we know can be expanded to look like this. We know that we are looking at the final time of 7 seconds and the initial time of 2 seconds, so we can easily fill in our initial and final times. For the velocity values, we must look at our points on the graph. At the time 7 seconds, we know that the object has a velocity of 5 meters per second, and at a time 2 seconds, the object has a velocity of 2 meters per second. We can further simplify this equation, and we find that the object has an average acceleration of 0.6 meters per second squared. One quick thing to note here is that the change in time must always be positive. A negative change in time suggests that you went back in time, which the scientific community has yet to figure out how to do. So we know if you have a negative time, you filled out the equation incorrectly. Let's do another example. Let's find the average acceleration of an object between the time 3 to 5 seconds. At the time 3 to 5 seconds, the object has a velocity of 5 meters per second. And at the time 5 seconds, the object has a velocity of 7 meters per second. Let's place these values into our average acceleration equation. We know that our change in time must be positive, so we know that the time must be 5 seconds minus 3 seconds for our delta t. And then we can place in the corresponding velocities. So we know that the final velocity must be 7 meters per second, and our initial velocity must be 5 meters per second. Once we simplify, we can find that the average acceleration is 1 meter per second squared. If we look at the graph a little bit more, we find that the slope of the line connecting these 2 points is also 1. Just like the position versus time graphs, we know that there is a connection between the slope of the graphs and the quantity that we have recently covered. So in this case, we know that the slope of a velocity versus time graph is equal to the acceleration of the object.